when y is a function of x, that is, y is equal to f of x. Say for instance, y equals to x squared. In this kind of relationship, y is said to be expressed explicitly in terms of x. But sometimes y may not be expressed explicitly in terms of x. So what are we saying next? Consider the kind of relation x squared y plus xy cubed plus 3x equals 0. As you can clearly see that in this relation, y is not equal to a function of x, but instead they are both attached together as a relation. In this kind of relationship, we said that x and y are expressed implicitly. And that is the purpose of this video. In this video tutorial, you're going to understand how to differentiate implicit functions. The process of differentiating implicit functions is called implicit differentiation. So let's begin with an example. Example number 1. Consider the function x squared plus y squared equals to 4. The goal is to determine the y dx. To differentiate implicit functions, all we need to do is to differentiate term by term. But for the y variable, we have to treat it as a function of x, which means we are going to differentiate it with respect to x. But for any other term, we differentiate them with respect to whatever they are. So what are we saying next is? The derivative of x squared with respect to x will simply be 2x. Well, it's supposed to be multiplied by dx. But notice that this cancels and left over is 2x. What does this mean? It means we are differentiating x with respect to x. So therefore it cancels out. Perfect. Now for the y squared to differentiate it, we have to consider differentiating with respect to x. So differentiating y squared will definitely give us 2y, but this has to be multiplied by the y dx because we are differentiating it with respect to x. We have to show it up so people can know when they see it. And this is equal. So when we differentiate the constant with respect to it, that gives us 0. As the derivative of constant is simply 0. Now at this point, the goal is to solve for the y dx. So instead, we can subtract negative 2x from both sides. Okay, or subtracting 2x from both sides. So we have 2x plus 2y dx minus 2x equals 0 minus 2x. And this cancels, you notice. Left over is 2y dx equals negative 2x. And at this point, you can divide through by 2y. And eventually, we can have the y dx to be equals to the 2 cancels, negative x over y. And this is our differentiation or the derivatives. And that's how to easily and mentally differentiate implicit functions. Now to understand more better, let's consider more examples. Example number 2. Consider the function yx squared plus y squared x plus 4x equals to 1. So let's begin our differentiation. Now when they are attached together like this, we differentiate them term by term. Then we associate them with a positive sign. But be careful, sometimes they might have a coefficient which have negative sign. So in this case, you will distribute the negative sign along. We are going to consider a situation like that. But let's begin with this one. So first, I'm differentiating y with respect to x. The derivative of y is just like y raised to power 1. And when the 1 comes to the front, we subtract 1 again. That will just be 1 times y raised to power 0. That's just 1. Perfect. So the derivative of y is 1. But don't forget, we are differentiating it with respect to it, so we are multiplying with the y dx. Now you treat x squared as a constant. Assume it's a constant, so we are still multiplying it with x squared. Now on to x squared, we now differentiate the next term x squared. Then we will treat this as a constant. So you now use positive sign to associate them. Plus y, derivative of 2x, derivative of x squared is 2x times 2x. Now, since we are differentiating x with respect to x, we don't need to multiply by anything. Perfect. Then plus onto this one. Derivative of y squared, that gives us 2y. Don't forget the constant x. Though it's not a constant, you are just treating it as a constant. Times x. Then times, since you are differentiating the y function, the y dx. Now on to the next term, derivative of x. It's just x raised to power 1, so that will be plus. Then we have y squared as a constant times 1, which is x. Then derivative of 4x, that's just 4, plus 4 equals derivative of 1, that's just 0. Perfect. I hope you grab the concept. So the y we can multiply now. We have x squared, the y dx, plus 2xy, plus again 2xy, the y dx, plus y squared plus 4 equals to 0. So now, once you have it, the differentiation on ground, you can just try and solve for the y dx. So we are taking this and all these two terms to the side. Okay, that's what we are doing right now. So we have x squared, the y dx. So we are just trying to isolate the y dx, plus 2xy, the y dx, equals, so when positive 2x comes to this side, it becomes negative 2x, negative 2xy. When this comes, negative y squared, negative y squared. When this comes, negative 4. So now I can take the y dx as a common at the left hand side. And we have the y dx in the bracket of x squared plus 2xy equals negative 2xy, negative y squared, negative 4. Perfect. Now proceeding forward, we can now divide through by this term. Then we have the y dx times x squared plus 2xy divided by x squared plus 2xy. Then that is equals to negative 2xy, negative y squared, negative 4, all divided by x squared plus 2xy. Perfect. Now this cancels out and we have the y dx left over to be equals to, so instead I can factor out minus signs. It is common, minus 2xy plus y squared plus 4 and eventually divided by, or entirely divided by x squared plus 2xy. And that will be our final answer to this problem. On to example number 3. Consider the relation or the function 4y squared x minus 5x squared y cubed, then plus 4y equals 0. So don't forget we differentiate term by term. So let's focus on y squared. Now we have 4x as a constant. So we have 4x times the derivative of y squared is 2y times, since we are differentiating y function, the y dx. Perfect. Now you can see, we can now move to the x term. Then don't forget we are using the plus sign, plus, because there's no negative part, plus, now constant is 4y squared. Term by term, why you treat any other thing as constant. So 4y squared times the derivative of x is simply 1. This one. Now on to this second term. Don't forget the minus belongs to the second term. So the first, let's take differentiate this, because this just follows how it appears. So we're focusing on x squared. So constant is minus 5y cubed. Perfect. Derivative of x squared is 2x cubed. Now on to y cubed. Constant is minus 5x squared. Then the derivative of y cubed gives us times 3y squared times the y dx. Okay, so I brought the 3 to the front and I subtract 1. So 3 minus 1 gives us 2 and the 3 comes to the front. Well, my writing is too big. Now the derivative of 4y, where should I put that? Let me just put it there. But it's continuation, don't forget. The derivative of 4y is 4 The first part is 4 plus 4. The derivative of y is times 1 over the y dx. So the 0, the derivative of 0 is still 0. Okay, so we can continue. Now let's multiply 4x times 2y times the y dx. That gives us 8xy, the y dx. Now we have plus 4y squared times 1. This gives us plus 4y squared minus 5y cubed times 2x. That gives us 5y cubed 2. Okay? My bad. That gives us 10y cubed x. I multiply the 5 and this time is perfect. Now 5 minus 5x squared times 3y squared. That gives us minus 15x squared y squared. Don't forget the y dx. Okay. Now we have 4 times the y dx. Okay. Plus 4 the y dx equals 0. Okay. Now the goal is to isolate the y dx. So the terms with green line under them are the ones with the y dx. So let's combine them. While the terms with which are circled with red color, we are taking them to the other side. Okay. So therefore we have 8xy, the y dx, minus 15x squared, y squared, the y dx, plus 4 the y dx equals, now when this negative 10y cube x comes to this other side, we have 10y cube x, and when this positive 4y squared comes, we have plus or minus, okay, minus 4y squared. Okay. Now let's factor out the y dx. So we have the y dx in the bracket of 8xy, okay, and minus 15x squared y squared plus 4 equals 10y cube x minus 4y squared. Perfect. Now let's move on. So now we can divide through the y dx times 8xy minus 15x squared y squared plus 4 equals 10y cube x minus 4y squared. So we can divide through by 8xy minus 15x squared y squared plus 4. Minus 15x squared y squared plus 4. Okay. So left over, the y dx in this case is equal to 10y cube x minus 4y squared. Oops. And entirely divided by 8xy minus 15x squared y squared plus 4. And this is the y dx for this problem. So I want to believe that with these few examples, you should now be able to solve problems involving implicit differentiation, as this is how it usually used to come. If you have any questions, feel free to let me know in the comment section below. And if you have any challenges, just let me know. Thank you. Here is your exercise. And that is where we are going to end this video tutorial. So this is your exercise. Feel free to share your solution with me. In the comment section below. Consider the function or the relation x plus y all squared equals 5. Determine the y dx. Thank you. Bye for now.